Okay, we're still on question number one, but now we're on part B. So we read through one, the question, and then we're doing the parts. We did part A, now we're on part B. And certainly I hope you retain what we did in one and in A. All right, let's go to the whiteboard. And I got to open the whiteboard up. I must have closed it. So just a reminder of things that we did in the past, and this was done, I have to read the question again. This was done in part one. So in part one, we're still doing question number one. And what we're doing now is the perimeter. So let me just remind you, we have a triangle. The triangle looks like this over here, sort of, anyway. There's a point here. The point here, I think, was 1K. The point over here, oh, by the way, this point over here is the origin, 0, 0. And this point over here was, the x value was tan theta plus k. We've already derived this, by the way. There's no need to rederive. Comma 0. And the y coordinate was, I'm trying to go from memory over here. It was k plus tan theta, or yeah, tan theta plus k, sorry. Again, we derived that all up there. And this is going to be 1b, all right? So we did this in 1a, now we're on 1b. And 1b asks for the perimeter. And they tell you what it is, they just tell you to verify it. So it shouldn't be so bad to verify something. So the perimeter, right, they call it the length around. Let's just do this section right over here first. And that length is pretty easy. It's just going to be, let's see, tan theta. I'm looking at my picture to do this, by the way, plus k over the tangent of theta. So that's done. Let's do this one over here. These are easy guys doing. That's why I'm doing that first. Plus, well, that's going to be tan theta plus k. All right, so we got two sides. Now we do the third side. The third side's going to use distance formula. That's problematic, but let's write it down. And let's see. Well, it doesn't look that bad, actually. I mean, the change in the y's, that's going to be tan theta plus k. Oops. Let me just go get my eraser out. So tan theta plus k, and it would be minus 0, by the way, but I'm not going to write that down. So squared plus this over here, which is going to be 0 minus that thing, and I'll write this over here. I'm not going to put the 0 down, but I'll put minus. That's going to be tan theta plus k over tan theta, and that's going to be squared. Well, it doesn't look like what they say it looks like, so I got some work to do. And the work is going to be work, actually. So the first term is this guy over here. I'm seeing this as 1 plus k over the tangent. I'm going to write it as a cotangent now. Next up, I have tangent theta plus k. Then I got this over here. And I'm noticing about this over here that actually it looks like it might simplify nicely. And the reason for that, it looks like there's a common factor between those two terms. Again, the minus, this is just squares off, so it's gone. So I'm really just getting tangent of theta plus k quantity squared times, well, it's going to be 1. It's tougher. I think about this. Plus, well, that's going to be the tangent squared in bottom. So I'm going to say cotangent squared theta. Let me stop for a moment, make sure I did okay. I think so. And I'm looking at this over here. The thing about this is that the theta has a restriction on it, and the theta is between 0 and pi over 2. So I know the tangent function is positive on that. And they also told me the k is greater than 1. So I can start to remove the square root symbol. And I'll write this over here. 1 plus k cotangent theta plus tangent theta plus k plus, I'm removing the square root there. Because the square root of that is just tangent theta plus k. And I'm not worried about, that's a positive number, I'm not worried about it. In other words, no absolute value symbol. And then I got this square root of 1 plus cotangent squared. All right? Now, I'm going to say that identities are nice to know. And one thing I was going to do, some of the Pythagorean identities down for you. I got sine squared plus cosine squared theta equals 1. You could divide through by, sine squared. You would get 1, and cosine divided by sine is cotangent. And then 1 divided by sine is cosecant. All right? So that's not so bad. So I think I know this one over here, and this would just be cosecant. All right? Now, before I go on, I want to point out we're still in this region over here, and it's still a positive number, the cosecant there. So I got something that looks pretty simple. I got P equals 1 plus, it may not look like what I want it to look like yet, but I'm getting pretty close to it. And if it doesn't look like what I want, I'll probably say I made a mistake somewhere. And let's put this over here. You're going to get plus the tangent, theta, plus k, times the cosecant of theta. Well, it doesn't really look like what they say it looks like, but I'm going to start to rearrange things. And I'm going to start to pick things off. And I'm looking at the actual printed paper now. And I see the 1 plus tan theta. That's the first thing I see. So I see this, and I see that. And then I see a secant. I'm not seeing that yet. All right, so I'm gonna write down, k, and then I'm gonna write down cotangent theta plus k, taking these two terms right over here. And this over here, I'm gonna distribute now. It's gonna be tangent, which is sine theta, over cosine theta times the cosecant, which is 1 over sine theta. And that's going to be plus k cosecant theta. Let's keep moving. I get P, 1 plus tangent theta. I'm looking at this over here, and that's just secant now. All right, the sines cancel off, and I get secant. I'm going to put plus secant down. I'll clip these off for you as I'm doing it. And then I see this k. I'll write this down. I'm going to factor it out because I see they did that. So I'll say k. And then I'll say 1. And then I'll say cotangent. And then I will say cosecant. Now we did what they asked us to do, show it's true. And that is true. So it's a QED at this point. We're done. We'll go on to C, which may be more difficult. I don't know. We'll read it. Thank you.